Hey guys, welcome back everyone. Can you hear me? Hello?
Yes, sir. Yes, yes.
Thanks. So guys, let's recap the yesterday class. So yesterday we have seen whatever the masses type of the BGP. So we have gone through the open masses, right? Then we have discussed about the key pair masses. Then we have discussed the notification masses. And also we have discussed the update masses, right? So we have four types of masses. Someone mic is on. So we have four types of masses in the BGP. So in the open masses, whatever the information are present in the open message, you will have a ACE number, right? You will have a own identifier. We can say that router ID. Then after that, you will have a hold on time, and lower hold on time is more preferred, right? And then also that we have a BGP version. And by default, the BGP version 4 will be enabled, right? We have a four types of version. We have a version 1, version 2, and version 3. But these three versions are totally a class full. So right now in this market, we are not using this thing. By default, version BGP version 4 is running on the 12.0 as version and 15.0 as well. And in a Cisco CLI, you cannot change the version. You cannot change the version, right? So in the BGP open message, you are sending all this information, except this information. Also, one more thing opposite, that is a optional capabilities that we are going to discuss in the later classes, not now. But these are the most important things about the H number, own router ID, hold on time, and BG version. So if the two router, for example, router number 1 and router number 2 has a 50 second is a hold on time and 180 second is a hold on time, so they will negotiate with the lower hold on time, 50 second. Okay. Now, next thing is the keep lab message. In the keep lab message, what happened? The router will just send the empty packet. This is the keep app is a totally empty packet. We are not going to put any extra information over there. So if you're not going to put any extra information, what happened? You are just going to reduce the burden on the router, right? So it will reduce the wastage of the bandwidth of the link as well as it will reduce the wastage of the bandwidth of the link as well as, right? So open message is just used to form the neighborship, right? Open message you just used to form the neighborship, and where the keep app message is going to maintain the neighborship, right? After that, we have seen the notification message. Notification message will be sent whenever the router will generate the any problem. For example, if you got any error between the R1 and R2, for example, if this both router has the same router ID 10101, and if this router has also 10101, it will generate the notification message. For example, on a router number 1, if you configure the wrong AH number, then it will again generate the notification message. Notification message means what? Something is problem, right? Then after that, we have update message. In the update message also will be our three values in the update message. The one we have a oh, my print is not working. Update message also have three values. One we have a withdrawn routes, right? Then after that we have a BGP path attributes. The path attributes is nothing but we just have a extra information. And then after that we have a NRI. NRI is what? It's a network layer utility information. So this NRI will be categorized, further categorized in the two ways. One we have a prefix length. Sorry, one we have a prefix. Another we have a prefix length. Prefix means what? We have 1.0.0.0.0.0. This is the prefix, and 255.0.0.0.0. It's a prefix length or subnet mask information. So we have four types of message in the BGP. So whenever the router will first form the neighborship, right? For example, router 1 and router 2, whenever this router will first form the neighborship, right? In that case, what happens? First, they will complete the three-way handshake. Once the three-way handshake will be completed, then router 1 will send the own open message, router will send the own open message. If the parameter will be matches, right, whatever the neighborship criteria will be matches, after that what happened? This router will exchange the keep alive to maintain the neighborship. And if you have any update, right, if you're going to advertise this route via using the network statement, then router will send the update packet to the router number 2. Whenever the router is going to make some changes in your network, right, the router will send the update. Mic is on. And notification message only comes in the picture whenever you have some error, right? These are the message type yesterday we have discussed. After that, we have also discussed about the BGP network statement. If you remember that in the IGP network statement, first go for the IGP network statement. The IGP network statement, how does this work? It's first enable the interface. Second, it join the multicast group. Third, it advertise the route. And in the case of GRP, it put the route in the topology table, right? But in the BGP, what happened? The network statement is only going to advertise the route. It only advertises the route. That's it, nothing else. So this BGP network statement works on the two ways. It totally depends on the auto summary concept. If your auto summary, so guys, I'm just recapping, right? Just give me 2 minutes. So if the auto summary is enabled, if the auto summary is enabled, if the auto summary is enabled, you don't need to perform the match, right? If the auto summary is disabled, you need to perform the exact match, right? And how do I advertise the route in the BGP? We have a two statement. So either you can put the network, and then you need to define the 1.0.0.0. For the classful, you can use this command, right? But if you have a classless, you can also use this command network 1.0.0.0.0, then use the mask keyword and define the subnet mask information. So both command will be work for the classful. But if you have a classless, so this command is only work for the classful. But if you have a classless network, for example, I have a network 1.1.1.0, then you need to use this command 255.255.255.0. So in a classless, we need to define the specific network bit and host bit as well as over there, right? You need to define the subnet mask information as well as. That's the meaning of exact match. And by default, someone mic is on. By default, auto summary is disabled. Disable means what? It's off in 12.0 as version and 15.0 as well. By default, auto summary is disabled in the 12.0 as version and 15.0 as version as well. So these are the things that yesterday we have discussed, right? And also we have discussed that whenever the router one will form the neighborship with the router number two, right? It first extends the three-way handshake. Once the three-way handshake will complete, they will extend the open message and keep the message. And whatever the TCP information will be there, whatever the states of the information, the message exchange, all this TCP information will be stored in the one database table. And that database table is known as a TCB, transmission control block. And this TCB is going to contain the information of the TCP state, TCP message, connection type, port number, and each and everything. Whatever the transport connection we have, or active or passive, everything is maintaining the TCP. TCP is nothing like that. It's just a one database table where the all TCP information are present. And every socket, or we can say every TCP session, has a separate TCP block. Every TCP session has a separate TCP block. For example, if this router number one and router number two, and I have a 12.1 and this guy's a 12.2. Let me show you this thing, right? Let's show you the practical, then you will understand very well. So we have a this ace number one over there, ace number two, this guy. And if you see, we have a 1.1 and we have a 2.2.2. So let's take a CLI of this person. Two. If you go to R1 and I put the command show IP interface brief, let's verify the first brief configuration. So all I have IP addressing on R2 as well as show IP interface brief. They don't have IP address. Let's configure it. 12.2/24 no shutdown. And I have interface loopback number one IP address will be 2.2 and loopback does not have a MAC address because it's a logical interface. It's not associated with the any kind of physical. So now if you see what I'm going to do, I'm just going to create a one connection router BGP number one. BGP router ID you can define manually. It's a 32-bit number. It's and always you can represent in the IPv4 format. And I said the remote edge will be on R2 as well as I said the router BGP number two. BGP router ID you can define to the and make a habit of this thing. Always define router ID manually. But always define router ID manually. Always. Don't rely on the loopback. If you're not going to define what happened, first the preference will be manual, right? Second preference will be highest loopback, and third preference it will go for the highest physical interface. So always better to define manually router ID. Okay, now just wait for some time. We have a neighborship, right? We have a neighborship. What I'm going to do, if you see show TCP brief, we have a one TCP session, right? And this TCP session information will be stored in the TCP block, and this is the identifier of this TCP block. What I can do over there, I'm also going to form the neighborship with this person now. Neighbor, remote edge will be one neighbor, neighbor, eBGP multi-hop, two, right? Because by default, eBGP has a single TTL value. If you see, because right now we have an eBGP connection, ACE number one and ACE number two, right? So we have an eBGP connection, two, and I want to define IP route, zero, okay, not zero, zero, IP route, one, because we need a reachability, right? So you cannot use the static default route over there because default route is not a reliable. Router BGP number one. Neighborship I'm going to form the 2.2.2. Remote edge will be two. Neighborship with the 2.2.2. Update source loopback number one. Neighborship with the 2.2.2. eBGP multi-hop. And I go want to configure IP route 2.0.0.0. Next will be 12.2. So if you see by default the eBGP has a TTL value one. By this is the default behavior, right? And IBGP has a 255. And if you just put this command, if you see, I just put the command eBGP, I didn't define any kind of multi-hop over there. So by default, it will go for the 255. What I'm trying to show over you, see right now, if you see, this router has a 12.1. So I have formed the two logical connection, right? Sorry, I have formed the two neighborship. One, I have formed the neighborship between this guy and this guy, and we have formed the neighborship between this guy and this guy. So basically, how many TCP system or router will maintain right now? A router is going to maintain two TCP session. One TCP session is going to maintain by the this person to this person, and one TCP session that I'm going to maintain from this person to the this person. So on a router number one, you will have a two TCP socket. And as I told you that each TCP session have a separate TCP block, and that has a own identifier. So this guy has a own identifier, or this guy has a own identifier. My state is established, right? So if you see show TCP, copy this guy and put the enter. So this guy is going to maintain the own information from here to here, the first information. If you go for the second one, same thing, just need to copy the TCP, show TCP, TCP, hit enter.
La, like, do we need static route is necessary over there?
See, either you can use the see reachability must be important because it works on the TCP, and TCP is a reliable protocol, right?
Okay.
We need a reliability. How do I need a reliability? So you have to define the same person in your routing table. You cannot use the default route in this case. If I'm going to use the default route will be not work in the BGP navigation.
Yeah, la, got it.
So either you can use the static route, either you can advertise this in the EHGRP. I just need a reachability, except the default route. Okay. Now I want to also show you the one more thing before I'm going to move to the BGP state. I want to show you also more thing. Let's do one thing. I'm going to create some loopback on R2. 101, 2.1, 3.1. Okay. And if you see interface loopback number two, IP address will be This is just beyond the syllabus. I just want to show you something like 2.1 slash 24, 3.1 slash 20. What I'm going to do, just to provide the reachability between R1 to this guy, what we are going to do, I'm going to enable the AGRP. Advertise all the route. Advertise all the route. Done. And on R1, I'm going to make a one loopback mode, interface loopback number 4. That's our 4.4.401 slash 24. And we have a, this guy's a 4.3. What I'm going to do on a router number 2 right now, on a router number 2, I'm going to make a summary address, right? Try to understand the concept over there. EHRP number 1, 248, right? Dot 0. So what router 2 is doing, router 2 is will send the summary address to the R1. This is the 192.168.0.0 slash 22. So in the R1 routing table, we have a slash 22, right? Show IP route. Okay, how the slash 21 is coming? What command I've been. Okay, I need to remove the previous one. So now slash 22 is there. What I'm going to do right now, I'm just going to make a neighborship between this person to this person. What I'm going to do, I say that router BGP number 1 neighborship, I'm going to form with the 2 update source loopback number, which loopback is there? 4. It's a loopback number 4, right? So neighborship, I'm going to form with the, this guy, loopback number 4. Neighborship, I'm going to form with this guy, eBGP multi-hop 2. Come back to the R2, router BGP number 2, do show run section. Loopback number 2 is there, right? So we can do one thing, neighborship, I'm going to form with the 4.1. Remote edge will be 1. Neighborship, I'm going to form with the 4.1. Update source loopback number 2. And neighborship, I'm going to form the 4.1. Remote edge will be, sorry, eBGP multi-hop 2. Try to understand one thing over there now. What happened? I'm forming the neighborship. Guys, my conclusion is very simple to all of you. My conclusion is very simple to all of you guys. On R1, we don't have an exact route. We don't have an exact route. On R1, if you see what command I've defined, on R1, I defined the command line. Do we have an exact route over there? No, we have a summary route. But still, we are able to form the neighborship between this person to the this person. So how many logical connection they have? Sorry, how many TCP system they have? One TCP system between this guy, another TCP system between this guy, and another TCP system between this guy to the this guy. So R1, someone mic is on. R1 is going to maintain the three TCP system. The main agenda is very simple, guys. We are able to form the neighborship if you have a summary address as well as only the one case the router will not form the neighborship, that is default. That is only one reason. Exactly, number of neighbors, number of TCP system. Number of neighbor, number of TCP system, and number of TCP system, number of TCP. Right? Number of, see, it is something like that. Mhm. Number of neighbor, number of TCP system. Number of TCP system, number of TCP. Transmission control block. All clear? Now, the next thing is that, do you know what happened if you see one thing? Show IP TCP brief. So we have a show TCP brief. We have three sessions, right? All good. And if you see show IP BGP summary, I have a neighborship. All three neighborship we have done, right? Do you know whenever the BGP router doesn't matter, I'm talking about the IBGP or EBGP, doesn't matter. Whenever the BGP router, whenever the BGP router will form the neighborship, whenever the BGP router will form the neighborship between this guy to this guy, or either this guy to this guy, or either this guy to this guy, every BGP router has gone through the multiple states, or we can say that every BGP router has gone through the multiple steps, and that steps is known as a BGP states. It is something like that. For example, this is one building, and this building will floor number 1, floor number 2, and floor number 3, right? And there's a one guy over there. That guy name is Kumar, right? And this is the rooftop on the 4th floor, foreign wall, right? So what happened on the rooftop of the foreign wall? This person wants to go, right, and but there is no lift in the building. There is no lift in the building. What happened? First floor, second floor, third floor, and fourth floor. This person, this Kumar, has to meet someone on the rooftop. This is the 4th floor over there, and the 4th floor there's some restaurant over there. So what Kumar will do in this case? There is no lift, so Kumar has to follow the stairs, right? First it will go to the first floor, then second floor, then third floor, and then it will reach to the fourth floor. Same thing before router. Before router is going to form the neighborship, before BGP router is going to form the neighborship, the router has to move, the BGP router has to go through the multiple steps, and that multiple steps is known as a BGP states. It is same like a OSPF as well as, right? In the OSPF also we have states over there. In a EIGRP also we have a pending state and an up state. Same thing in a BGP, what happened? The router has moved to the multiple states. Exactly like OSPF never state, right? So in the BGP, what happened? In a BGP, we have a 6 states. The first state we have a ideal, then we have a connect, then we have a active, then we have open sent, then we have open confirm, and then we have establish. Total we have a 6 state. These 3 states, if I'm going to break this all these 3 states, so we have a this is the partition point over there. So these 3 states, right, is totally going to represent that of TCP. This 3 state is totally going to represent that of TCP. Why I'm saying this thing? If your TCP is working fine, if your TCP is working fine, then it will move to the next state. If your TCP is not working fine, it will stuck in the either ideal, either connect, or either active. If your TCP is working fine, then it will move to the open set, open confirm, establish. Otherwise, never they will never move, because in this open sent state, the router will send the first BGP message, that is a open message. Name says open. So this 3 state is totally responsible for the TCP connection, and the remaining 3 state is going to be responsible for the BGP. The first state of the ideal, let's do one thing. I'll show you the finished state machine as well. So I'll take a screenshot of this person and try to analyze each and everything. Okay. See, I'm telling you, in the interview, they will not ask you the explanation of a BGP state, this finite state machine. But if you have a knowledge of the finite state machine, this finite, how this the state is working fine, then you can easily troubleshoot your BGP. Okay. So let's see how this states are work. What I can do also, I can copy this line. Okay. Okay. So, and it's fine. Copy. All good. Just give me 2 minutes. Okay. Now let me make a start over there, so that you can easily understand this behavior. Because this is the most important. See, I can explain you in a easy way as well as the BGP states, and you will also learn that one. It's not a very hard. But for the troubleshooting purpose, I'm just going to explain the finite state machine, right? So you can easily troubleshoot the BGP. If you are getting any kind of troubleshoot over there, you can easily troubleshoot. And how these things are working. Okay. So these are my I stand for this. I means what? I stand for input events. Right? This I stand for input events. Input event means what? Whatever the input that you are giving to the BGP, whatever the input that you are giving to the BGP, and after that, what BGP will react that one. Okay. So now the first state we have, the first state we have ideal state. The name suggests that it's a ideal. It means that whenever you're going to put the router BGP command, whenever you're going to put the router BGP command, and whenever you're after you're putting the neighbor statement, in that case, what happened? BGP always begin with the ideal state. In which state, what happened? It is going to refuse all the incoming connection. So, for example, on a router number one, on a router number two we have, and this states have the same similar features of the other if you go for the IBGP or EBGP, they have the same mechanism. So what happened if I'm going to put the command router BGP number one on our router number one, right? This is the AS number one and this is the AS number two. What happened if R2, if I have enabled the BGP on this guy, so what R1 is going to do, it is going to refuse all the connection right now. In this ideal state, what happened, start the I'm only going to start the event number one. And in this event number one, what happened? The BGP will be start. Once the BGP will be start, I'm going to utilize all the resources. If you remember, the first day of the BGP lecture, I told you what's the minimum requirement of the BGP. At least you need to have a, I'm talking about according to the production network. At least you need to have a 256 MB RAM, right? At least. Right? So what happened in the ideal state? What happened? The BGP will be start because it's going to start the event occur, and it is going to resource all the BGP. At the same time, what happened? The BGP router is going to start the connect read write time and initialize the TCP connection to the neighbor. It means that now when the router you have enabled the BGP on this router number one, what happened? If you remember, after putting the neighbor statement, it is going to reserve the port number 179, right? And they will start listening on this port number, right? They will start listening on the port number. At the same time, what happened? They will start the one timer that is known as a connect read file timer. And by default, this connect read timer is a 120 second, and you cannot change this timer. And this connect retry timer for each subsequent attempt will be become the twice from the previous one. So in this ideal state, what happened after putting the neighbor statement? What happened? The BGP is going to start the BGP event, right? It is going to initialize all the BGP resources, and it is going to start the BGP connect retry timer, and that is 120 second by default. And after that, what happened? It will move to the connect state. So from here, can you see, from ideal state, I can move in the input event 1 will happen. That's the input event 1 is going to be a BGP start. I will move in the which state? Connect. After utilizing the all the resources, I will move in the connect state. At the same time, what happened? BGP retry timer will be that is 120 seconds by default, and you cannot change. And at every attempt, what happened? This timer will be become twice, right? You cannot change this timer. So after utilizing all the resources from in ideal state, what happened? I can move in the connected state. As the name suggests that. See, in the ideal state also we are doing the TCP connection, right? In the connected state, what happened? The name suggests that it's a connect. Connect means what? I'm trying to connect the BGP TCP system. I'm trying to connect, or we can say that I'm trying to form a three-way handshake. I'm trying to form the three-way handshake. The connected state is saying that I'm trying to form the three-way handshake. So in the connected state, what happened? In this state, the BGP process is waiting for the TCP connection to the neighbor to be completed, right? As I told you, the BGP in the connected state, what happened? The router is trying to connect the TCP system. If the TCP connection will be successful, the BGP process clear the connect retry timer and complete the initialization and send the open message. It means that from here, from connect state, if everything should be fine, right? From in a connect state, what happened? If everything is fine, then I can directly move in the open set. Try to understand one thing. What happened? From ideal, I can move in the connect state, right? From ideal, I can move in the connect after utilizing all the BGP resources, and I'm going to initialize the connect retry timer. From ideal state, I can move in the connect state. From connect state, in the connect state, what happened? I'm trying to form the three-way handshake. If the three-way handshake will be completed, I can directly move in the open send. And if I'm going to move in the open send, what happened? I can send the open message. That's how this point is saying, right? In this point, what he's saying that the TCP connection to the neighbor to be completed. If the connection will be completed, the BGP process cleared the connected retry timer and the complete initialization send the open message to the neighbor, and it will move to the open send state. But if the connection is unsuccessful, then the BGP process continue to listen the connection to be initiated by the neighbor and receive the connect retry timer, that is 120 seconds by default, and it will move to the active state. So from here, what happened? From connect, I can directly move to the open send as well as, or I can move to the active as well as. And I will move in the active state. From connect, I will move in the active state in which scenario? Input event 5. So what input event 5 is saying that BGP transport connection is open. He's trying to again form the neighborship. But again, the problem is that from connect, right? From connect, I can move in the which state? Open set, right? If the TCP connection is successful. If the TCP connection is unsuccessful, I can move in the active state, right? And I will receive the connect retry timer. Take example, what happened if the connect retry timer expand? That is 120 seconds by default, right? So it should be expired, right? Connect retry timer could be expired. So in this, while in the connect state, if the timer will expire, The timer will reset and another attempt is made a TCP connection with this name. So if the connect retry timer will be expired in the connect state, then still what happened? This guy has the ability, it will present into the connect state. The input event 1 and 7. What is saying that? Input event 1 is saying that BGP still will be start, and 7 is saying that the timer will be. So in this state, only two cases will be happen. Once your timer will be expired, and of course, if the timer will be expired, I will again reset the timer, or of course, if I'm going to reset the timer, the BGP will be start. That's the meaning of input event will be 1. But again, what happened if any other bad event will be happen? Bad event in the sense of what? If any input will be caused, I will move in the ideal state. So from here, from connect, I can move in the ideal state as well as. In which case, if the input event 2, 4, 6, or 8 and 13 like this, if the BGP will be stop working, if the BGP transmit connection will be closed, TCP connection will be closed, right? If the BGP transfer fatal error will be happen, if any like a hold on time expire of any this event will be happen, I can move in the ideal state as well. So we can see that from connect state, right? From ideal, I can move in the connect. If the three-way handshake will be successful, I will move in the open send. If timer will be expire, if timer expire, I will still present in the connect state, right? Still in connect, right? If any fatal will be any fatal error will be happen, I can move in the ideal state, right? If any error will be happen, I can move in the ideal state, or I can also move in the active state from the connect. If TCP connection is unsuccessful, the BGP process continue to listen for a connection. If the BGP process continue to listen for the connection, it means that timer is not expired. I can move in the active state as well. So from ideal, I'm going to utilize all the resources. I'm going to start my connectivity timer. I will move in the connected state. In a connected state, four things will happen. If the three-way handshake will be successful, move in the open center. If the three-way handshake will be unsuccessful, right? If the three-way handshake will be unsuccessful, I will move in the active state. I will move in the active state in only in the one scenario if the timer will be not expired. But if the timer will expire, then I will move in the connected state. And if any fatal error will happen, I will move in the idle state. Once the packet, oh sorry, once the BGP guy will move in the active state. In the active state, what they will do? Again, same thing. In this state, it is again going to try to form the TCP connection. If the TCP connection is successful, clear the connectivity timer, complete the initialization and send the open message, and it will move in the open send. So from active, it can also move in the open send. So from here, I can also move in the open send. If the TCP connection is successful, TCP successful, done. Otherwise, if connectivity timer expire, if the timer will be expired, connected. If the timer, as I told you that, if the timer will be expired, you always move in the connected state and reset the connectivity timer. So from active, I can move in the state as well as if the timer expire. Timer expire. Now, from active, the timer will expire. I can move in the connected state. What happened if any other input will be happen? I will move in the ID. So from here, I can also move in the So from active, I can go in the connect if the timer will expire. From active, I can go in the idle if any bad event will be happen. And from active, I can move in the open sent as well. So whatever the event will be happen, if you see from active, from active, if any event will be happen like regarding the input event 7, right? Input event 7 is saying that my timer will be expired. Then I can move in the connected state. But if any event will be happen 2, 4, 6, 8, this one from here to here, I will move in the idle. BGP stop working. I will move in the idle state. But if the transport connection is open, right, it means the TCP is successful. If the transport connection is open, if the TCP is successful, I can move in the open sent. Once the once the BGP person has moved in the open sent, it means that your TCP is working fine. If your router has moved in the open sent, it means that TCP is working fine. So in the open sent, what happened? In this state, as the name suggests that open message, an open message has been sent. The BGP is waiting to hear the open from the its neighbor. When the open message is received and all fields are checked, and if there is no error will be exist, sorry, if when the open message is received and all fields are checked, and if error exists, then the router will generate a notification message and it will move to the transition state. So it means that from here again, it will move to the, it means if any notification that I told you, notification message, what is used for the notification? If any bad event like a wrong AH number, wrong router ID, right? So it will move in the ID. Then if no error will be exist over there, right? For example, there is no error exist in the receive open message, a keep alive message will be sent and keep alive time will be set. The hold on time will be negotiate, as I told you that in the open message we are sending the hold on time and the smaller value will be agreed. And if the negotiated hold on time is 0, the hold on and keep lap timer are not started. And in this open message, what I'm going to determine is it the internal neighbor or external neighbor based on the HTML. So if somebody will ask you in which packet we are going to decide, if they would ask in the interview in which packet they will decide it is an internal neighbor or external neighbor. So the packet name will be open and which state, open state. The packet name is open message. In the open message, we are going to determine the peer connection is internal or external. And in the open sent state, we are going to determine if the peer connection is internal or external. So if the open message will receive, I will move in the open confirm. But if any event will be happen, I can directly move in the idle. So from open sent, what happened? A router can move in the open confirm. It means that router has sent the open message, right? And my neighbor also sent me the open message. So if the open message will be confirmed, right, because I'm sending you and you are giving the acknowledge of this open message, right, it means the open confirm is happening. So in the open confirm, what happened? If the open confirm will be received, right, in this state, what happened? The BGP process wait for the keep alive. If the open message, if the both the router is going to extend the open message, right, router 1 router 2 will extend the open message, what happened? They will move in the open confirm state. But in the open confirm state, what happened? The router has moved in the open confirm state. In the open confirm state, what happened? I'm just going to wait for the keep alive. If the keep alive is coming, let's move in the establish. If the keep alive is received, let's move in the establish. But if the notification is received, let's move in the idle. So from here again, I can move in the, from here again, I can move in the idle if notification is coming. But if there is no notification, I can move in the established. If keep alive, I can move in the established. Or in the established state, what happened? My neighbor will be fully adjacent. But from established state, what happened again? If any bad event will happen, like a router ID change, ASM mismatch, I can move in the ID. So again, from established, if everything is good, then it's fine, right? I can extend the keep alive. But again, from here, what happened? I can move in the established to the ID. That's the meaning. If you see this diagram, in this diagram, what happened? Can you see? Either you can go from connect, I can move in the ideal. From active, I can move in the ideal. From open set, I can move in the ideal. From open confirm, I can move in the ideal. And from established, I can move in the ideal. In an established state, that's the final state of the BGP. In the established state, I can only live in this scenario. Input event 1, that is going to BGP should be a start. 9, we are going to extend the keep alive, right? And the 11 and 12, that is going to depend on the receive keep alive and receive the notification. Sorry, receive the update message, not the notification. Only in this case, I will position in the established. This is how the BGP states are working, guys. If you see one more thing, I can show you in the practical as well as what I can do. I will just go through the, I've just removed all the neighborship, whatever the neighborship we have. Let me remove node out of BGP right now. And let's go router number 2, node out of BGP number 2 as well as, right? And I can do one thing. I'm going to say that debug IP BGP updates and debug IP BGP. Okay. And also debug IP BGP. Okay, states are not there. I can go events. I'm not interested. Okay, I can put the events and let's router BGP number 1. Okay, neighborship developer 2. Come on, remote is on 2. So this state, this 3 state is only going to respond for the TCP, guys. This 3 state ideal connect here only will respond for TCP. Wait for some time. So it's moving from the ideal to active, right? While they're moving the closing state, something is problems happening. Notification generated, ping appearing in the wrong is. So what command I did over there? Remote is 2. It's fine, right? Okay, I made a mistake, and it has to be router BGP number, no router BGP number 1. Should be 2. Neighbor should be 1. Now just wait for some time. I'll explain this debug myself. Let's just wait for some time. Always, from any state, router can move in the ideal state. Now, if you see what happened, I'll show you the first this debug message, right? Come on, let me stop this debugging. So right now, I'm present on router number 1, right? The user are present on router number 1. You need to analyze from the router number 1. So after putting this command neighbor to a remote edge number 2, right? What happened? If you see, I'm wait from the ideal to connect, right? Right, ideal to connect. Then from connect to what happened? I'm moving in the open set. Okay, so as I told you that you can move from connect to the open send directly, right? You can move, see this, can you see the green line? The green is moving from connect to the open directly, open send. So it's moving the open send over there, connect to the directly. And then what happened, I'm sending the open message. In this open message, what happened, I'm going to send the version number. That's by default BGP version 4, my is number 1, and I'm also sending the hold on time over there, right? And some optional parameters are also there, so we'll discuss this optional parameter later on, not now. And now after that, what happened, if you see, I went from the open send to the closing state. Why? I told you in the open send state, what happened, if you see this line, if any notification will be generated in the open send, I'm pausing the open send, right? If you see open send, right, outer one is present in the open send. So in the open send, what happened, if any navigation, if any notification will be generated, I will move in the closing state. So from open send, if notification generated, I can move in the, see this line, this wallet color, I will move in the ideal state, open send. And what is the error message coming? The peer in the wrong list. So where I'm moving in the ideal state. And from ideal state, what happened, again I'm trying to form the neighborship, and I will move in the active state. In the ideal, from active I can move, right? I'm trying to form the neighborship. Again, the next time what happened, if you see the, then I'll solve this error message. Then after that, what happened, active to open send, sending the open message, right? Open send. Okay, this is the notification message, where the confirm message, this one. Yep. So from open send, what happened, this open send, I can move in the open confirm as well as, and from open confirm I can move in the establish as well as, and my neighbor will be. This is how the BGP states are working, guys. If you do one thing, if you see that, let's enable debug IP BGP again, and debug IP BGP event and update. I'll do one thing in auto BGP number 1. I said the neighbor 12 or 2, right? Shut down. Just shut down this neighbor. I'll show you the again debug message. My neighbor has gone through the, from established to moving is the ideal state. You see, from established, right? So from this guy established, I can move ideal. Why? My neighbor is down due to the admin, because our network engineer has shut down this command. So my neighbor is down just because of the admin. So if you see show IP BGP summary, what happened? My neighbor is down just because of the admin. State is idle. Why the state is idle? In the ideal state, what happened? In the ideal state, only the one event will be happen. The BGP just start. In the ideal state, what happened? There's only one event, right? In the ideal state, the BGP start working fine. This one, 2 and 3. My neighbor is down. If you see the TCP connection as well, so TCP brief. I don't have any TCP connections over there because my neighbor is down right now. So what I can do, I'm just going to up this guide out of BGP number 1. So it's keep trying to form the neighborship, but it will not. 12 or 2, shut down. I'm just going to remove this command. Now it will move to the ideal to active, active to open send to open confirm, and then it will form the established. My neighbor will be. So now if you see, if my neighbor is working fine, I can get the show IP neighbor command as well as from this statement by putting this statement, sorry, by putting this command show IP BGP neighbor. So IP BGP neighbor, right? By putting this command line, I can also get the information. Right, I can also get the information, right? This is the external link, right? But this guy will give you the lots of information, and you see that lots of information they are giving. I'm not interested in the lots of information. So what I can do, I can just put the summary keyword. In the summary, what happened? I can get the information. Summary means what? I can see the my neighbor is working fine or not. So if you get the 0 value, 0 means what? How many prefix I have received from my neighbor? That's the meaning of 0. So I have never received, right? Because R2 is not advertising any prefix to me. If R2 will advertise any prefix to me, then I will put the contour over there. Okay, I have received the one prefix. So right now, R2 is not advertising any prefix to me because I'm present on R1. I'm checking my neighbor information, 1202. So my neighbor is 1202. This is the BGP version 4, right? By default, we have a BGP version 4. BGP version 1, 2, and 3. It's a class 4. So BGP version 4, my neighbor is running with the BGP version 4. This is my AS number, my neighbor AS number. How many messages I have sent and received? So I have received the 12 messages from my neighbor. I have sent the 13 messages. Table version is just going to represent at how many times your BGP table has been modified. This table version, guys, and this BGP version is totally different. This is the BGP version and this is the table version. Table version is just going to tell you how many times your BGP table has been modified whenever something has been changed in your BGP table. For example, let's go now to I'm saying that network 2.0.0.0. So what happened? R2 will send the update packet, right? R2 will send the update packet to the R1, right? This 2.0.0.0.0. So in this case, what happened? R1 has to modify the BGP table, right? So what happens? If you see, I have received the update from my neighbor 1202 about this guy 2.0.0.0. What I'm going to do? Show IP BGP summary. Can you see? My table has been modified. So previously, what happened? The prefix is 0, right? Now, so this option is just going to tell you how many prefix that I have received from my neighbor, or state is just going to tell you in which state my neighbor is stuck. So if there is a written anything, ideal, active, connect, open set, open confirm, then you will have this option is written over there. So there is no option in written. It means that everything is good. The 0 value is going to represent it's good, everything is good. If something is written like ideal, connect, open send, it means something is bad. For example, I said a router BGP number 1 BGP router ID I can put. Done. Show IP BGP summary. What happened? 1 minute. R2 has which identified. Do show IP BGP. Okay, BGP router ID is done. Same router ID. Show IP BGP summary. What this guy is saying that state is active. So if any notification will be generated, they will move in the any of the BGP states, right? Any of the BGP states, right? So this guy, let me correct this thing. I'll put the BGP router ID. Done. So it has to be from the neighborship, right? Now the BGP router ID is perfect. So both have a different router ID. It has to form the neighborship. Just wait for some time. Come on. So BGP is a little bit slow routing protocol, guys. So you just need to wait for some time, right? So my neighbor is up now, and if you see show IP BGP summary, what happened? See the 0 prefix for my neighbor. So this table version, guys, BGP table version and main routing table version is totally different from the BGP version. This will be always modified whenever something will be changed in your BGP table. So right now, if you see, I say that interface router BGP number 1, I'm going to advertise this route. So if I'm going to advertise, I'm going to add this route in the BGP table first of all. So IP BGP, can you see? I've added this information. I will explain each and everything. Don't worry what is the meaning of a star, less than, greater than, 0 matrix, each and everything I will explain you. I'm just right now. I'm just concerned about this thing, table version. This table version is totally different from the BGP version. BGP version always should be 4. BGP version always should be 4. But this table version will be changed according to your database. So not according to your database, according to your update. If any update is happening in your BGP table, this will be modified. Either you are going to add something in your BGP table. This is my BGP table. Either you are going to add something in your BGP table, or either you are going to remove something. This table version will be incremented every time. All clear, guys? Anyone has any questions? This is how the BGP states are working. Anyone has a question in the BGP states, you can ask me. So I'm done for the today, right? So tomorrow we are going to start from IBGP. So once we have done with the IBGP, in the IBGP we have a full mesh, right? We have a route reflector, we have a configuration part. Then we'll go for the BGP, eBGP, path attributes, aggregations are there, multiple things are there. No, today class is hot. Hot in the sense of what, Samson? Tough. Okay. So actually, this see, I'll tell you one thing. The class, isko koi, uh, see, the thing is that I'll tell you one thing. See, if you need a more detail, I can go in the more detail. If you want an overview, I can give the overview as well as like a configuration division number in the VTP. Exactly right, Kumar. Like a configuration division number, right? Like you can also say that's OSPF database table sequence number. In the sequence or in the database table of the sequence number, what happened? Whenever the database table will modify, your sequence number will change by 1, right? Same thing is happening. All good, guys. So hope this states are clear to all of you. Please go through the one time more video, right? One time and check all this info. I'm doing one thing. I will upload this books in the Google Drive link, right? So you can read from there. So it's the page number is 118, 118, right? You can learn from there as well. So here I'm done. Whatever the topics that I have covered till this point, I will tell you. So we have done with the BGP neighborship, either directly or indirectly connected. Someone mic is on. We have done with the network statement. We have done with the BGP states. We have done with the BGP masses. And we have also done with the internet connection type. That's a single home, multi-home, dual multi-home, dual single home. We have also done with the connection type as well as, right? So tomorrow we are going to start with the full BGP split horizon rule. That's very, very important. And it's very, very important for the interview round purpose as well as not B, it's an IBGP split. So tomorrow we'll discuss about how does the loop prevention is happening in IBGP at the same time EBGP. All clear? So guys, good night. Bye bye. See you tomorrow.
Good night, sir.
Yeah, thank you.